Sai Ram to all of you. Welcome to this session of study of chemical concepts which are called as adsorption and catalysis. Maybe the first word is not very familiar to you, but a similar word was familiar to you from your young age, and that was absorption, AB. A slight change in the spelling is seen, but then it's altogether a different concept. What's that? That we shall see. And catalysis, having seen a lot of organic chemistry, lot of reactions depend on substances called as catalysis. So you have heard the word catalyst, you have used it also in various reactions, but what are its properties, how do they work, all these aspects we are going to study in these topics. So the catalysis part will be studied at a later stage. At first, let us concentrate on what is this adsorption. So what's this? Generally, whenever you put a liquid on, say, a cotton bed or so, suppose your bed gets soaked, then what do you do in the first place is you take that bed and put it up for sun so that your water is removed out from that. Now what is that process is that the water is mixing inside the cotton wool which has been present. Whereas this term adsorption is nothing but you have a surface, other molecules come and settle on that, but they will not mix up inside. Where you can understand this aspect as if this is one surface, as a surface layer if we can have other molecules, for example. So some of the molecules I am just showing here in a different coloration. Now if this was absorption, then it would have mixed inside, but this is not absorption. The concept that we are now looking at, it is adsorption, where in these cases we shall consider the aspects where if a layer is present, molecules will go and settle on the layers only. So how do we come across this in our day-to-day life? Do we come across? Yeah, definitely. It is just that we would not have analyzed these situations, but these are part and parcel of our day-to-day lives. So first up, let us see what is this adsorption. We have a small definition of sorts where it says that the surface of a solid attracts and retains molecule. What do you mean by retain? It means that there is a surface and the molecules settle on that. Of a gas or a dissolved substance. By what do you mean by a dissolved substance is that suppose some molecules are mixed in water, say like sugar solution. So any dissolved substance also can be present on a particular surface which comes in its contact. Now this is only possible if there is a contact. Now you can't have a surface here and molecule at a particular height. This sort of a phenomena can only be observed whenever it comes in contact. So let me go through it once again. The surface of a solid attracts and retains molecules. These are the molecules, the dot forms which are shown. Of a gas or a dissolved substance which comes in its contact, these molecules remain only at the surface and do not go deeper into the bulk. Now the moment it goes into the bulk, that concept will become absorption, whereas adsorption stays only at the surface. The phenomenon of attracting and retaining the molecules of a gas or say dissolved substance basically on the surface and not to get into the entire system. So this sort of a concept is what we deal with as adsorption. So having seen this part now, we shall see some of the aspects that are being associated with this concept of adsorption. Now the moment you talk about adsorption, two things are clear, that you have a surface, you have some molecules on it. Now naturally when there are two different things, you got to name them. And that naming is shown here with a small diagrammatic view. So what is this? There is a surface, there are molecules. These surfaces we have called them, in this case if you see here, the surface which is shown here is black colored. Generally charcoal is a very good adsorbent. Now where do you see this charcoal? It is nothing but solid form of a carbon where it has a very good adsorption properties. It can attract molecules on its surface, doesn't let it inside. So we have a surface, we have different molecules. Now there are some molecules which are moving about in the container, but you can also see that some of them have come on the surface. So two terminologies here, one is adsorbate, the other one is adsorbent. So the solid surface on which the attraction takes place, we call them as adsorbent. And those molecules which get adsorbed, meaning that these are the free flowing molecules who, if they come in contact with the surface, will settle on the surface, will stay on the surface. So these two set of components, we happen to call them as adsorbate and absorbent. So this is about how the molecular arrangements are present in these cases. Moving on, a difference that has been put on paper here. We now must have understood the stark difference that can be seen between adsorption and absorption, where so this phenomena of adsorption is naturally different because the problem or the main source of difference you are going to see here is it is uniformly distributed throughout the body of the solid, which means that if there's a body, suppose you have a sponge piece. So what happens there, the moment water goes on that sponge, your water is circulated throughout the entire piece that you have. So that phenomena we tend to call it as absorption, because there is a uniform distribution, not just on the surface, even inside the surface also. But then the other aspect when you come across, adsorption is nothing but staying it on the surface. We have certain examples here. If you take calcium chloride, this is actually taken wherever you want to absorb water from substances you have heated. Suppose in practicals you form certain organic compounds by various reactions. Now what happens is, since the process generally will involve water for washing, cleansing and everything, so certain molecules of water will be there. So we have sort of a utensil of sorts which we call it as desiccator. Now in that what we do is we put up this calcium chloride. Calcium chloride is nothing but CaCl2. These molecules have very good capacity to absorb water from the surrounding which is there, which we actually call it as moisture, the water vapor. So this sort of absorption, this calcium chloride pulls away the water molecules that have been present around. So this is more of an absorption because it is actually pulling about. But if you keep the same sample in silica gel, now silica gel which is there, that will actually adsorb only on the surface. Now silica is Si, generally formed from silicon dioxide, and silicon dioxide you get it in sands, be it near the seashore or ocean. So this silica gel performs almost a similar job like calcium chloride, but the phenomena that they undertake is different. While calcium chloride will actually pull away the water in the form of absorption, whereas silica gel will have it only on the surface layer. So this is one important difference that we got to see between the two concepts of adsorption and absorption. Absorption, something we have studied from a young age, whereas this is a new concept now, and over a period of time you'll realize how important this concept is for our chemical studies. So moving on further now then. Some of the examples, since this is an introductory part, we shall look into some examples of adsorptions which happen in day-to-day life and even chemically also. Now say if you have some gases here, many gases are named here: O2, H2, carbon monoxide, chlorine gas, ammonia gas and sulfur dioxide gas. All this, suppose if you maintain a beaker and then if you close it, suppose you have oxygen gas here. Now what happens with this oxygen gas is, we know the properties of gas that the molecules are spaciously arranged. Solids, they are tightly packed. Liquids, a little bit open, whereas gases are spaciously arranged. Now what you see here is that the moment they are spaciously arranged, molecules will not stay at a particular place. They will be in continuous random motion. This aspect you have studied in the kinetic theory of gases in states of matter. So the moment the molecules do not stay at a particular place, it is but natural that these molecules will definitely hit the walls of the container. Now it could be on the sides, it also could be on the lid also, because the molecules cannot stay at a particular place, it will keep hitting the walls. Now the moment it hits the walls, naturally what is developed is pressure. The molecules are hitting hard, so one natural chemical factor that you can find is pressure. So the moment pressure generates, the pressure will definitely be more, but it is seen that if you have used, say, a charcoal which can act like an adsorbent, so the same beaker, if it contains some adsorbent, say like charcoal, the molecules, rather than being freely moving around and generating pressure, will settle on the surface which has been present. So what happens the moment you drag in the molecules, the pressure on the lid will definitely decrease. So that is what is been told here, that when you put these gases in powdered charcoal, it is observed that the pressure of the gas decreases. Why does it decrease? Because substances like charcoal will try to adsorb these gas molecules, thereby the effect or the hitting power of gases on the surface will reduce. So this is one general example that we see, though it is not a day-to-day occurrence that we analyze, but this is happening at every given place. We have some other examples like organic dyes, say methylene blue and all, where animal charcoal is used, and because of that, when you shake it for a long time, it so happens that the animal charcoal will actually act like an adsorbent. Where this is more, the moment it's a organic dye, it actually acts in the chromatographic methods. What is chroma is color. So what is happening here, the charcoal which is present is actually attracting the coloration matter which has been present. Other example is when raw sugar is passed, so that also becomes colorless. This is actually used in the sugar industry, where I'm not sure if you are aware that in the sugar industry, general sugar that we tend to get is the brown sugar. But then at home what we tend to eat is white sugar. Now what has happened to that coloration there is, such a process has been employed where sugar coloration has been dragged away and formed into colorless white components by these type of charcoals. What they also do is they try to remove all the impurities that are being associated with that. So these are the three examples that we have here, and let us see another example that is present here. So the same silica gel that we had looked into. So basically over a period of time, the silica gel will adsorb the water molecules that are being present, so that the presence of moisture around can be reduced to a large extent. So this is just a pictographical representation that we have of charcoal and silica gel, how the coloration keeps on varying over a period of time. So this is all about the introductory part of this segment, and let us see further aspects of this in the coming parts. Thank you. Sai Ram.